Okay, welcome to the Biotechnology station of Trailblazer 2. The purpose of biotechnology, bio meaning life, technology meaning something man-made is interacting with it, is to show the students how the many ways there are that man interacts with life to make things a little bit better for us. The next thing we have is an example of AR, also known as augmented reality. And right now they are using this sort of thing in medical schools to help train their medical students in what the organs of the body look like. We can take this and hold it in front of Jack, our augmented reality mannequin, and we can see inside of him, see his rib cages and his lungs and his heart. We can tap on this and we can get the ribs out of the way and get a better view of his lungs and his heart. We can drill down by touching this, and now we can see his heart. And we can go back to the original view. Engineers are doing research, and they're hoping one day to be able to achieve real-time imaging where the doctor will be able to hold a device in front of you and actually see inside of you just like this. Now, would you like to try this? The next thing we have is a digital microscope. This is a 1000 power microscope. What's neat about digital microscopes is you can remove them from their stand and you can look at things that are not in underneath the display. For example, I could look at the back of my hand here and I could see the hairs on my hand. Can you see the roots where they come into my skin? Okay, now we're going to let you try and do some exploring with the microscope. The next thing we have are our pulse oximeters, and we're going to put these on the student's index finger and push this button. It'll take about 8 seconds for us to get two readings. One of them is the percentage of oxygen in our blood, and the other one's the pulse rate. So you can see my oxygen level is at about 95%, which is actually a little bit lower than it should be. It should be at 96 or higher. And then the number at the bottom is the pulse rate. For an adult that is healthy, it should typically be under 100 beats per minute. The next exhibit at Biotechnology is our DNA exhibit. How many people have heard of DNA? It's called the building blocks of life. This is an actual human person's DNA sequence. You'll notice there are 4 letters that keep repeating, T, A, C, and G. But there are 10 billion possible combinations, so no two people should have the exact same DNA, with the rare exception of fraternal identical twins. And that's like 1 in about 5 or 10 billion. This right here is a standardized DNA sequence. If I line up the top left T and the bottom right T, you can readily see where they don't match. All of those are mutations. Some mutations are no big deal. For example, if you have any color eyes but brown or any color hair but brown, that's considered a mutation. Genetic engineers are doing research. They're figuring within about the next 10 to 12 years, they should be able to start tweaking our DNA before we're born. Once they're able to do that, within 3 to 4 generations, they should be able to eradicate hereditary diseases completely. So the next exhibit we have is our robotic surgery display. If they were going to do robotic surgery on my stomach area, they would cut 3 or 4 incisions about the size of my finger. In one of them they would put a lighted camera, and the other ones they would put surgical instruments. They could then see inside of me as they operate on me. There are a lot of advantages to robotic surgery. One of the advantages being because the incisions are so small, they typically don't have to stitch them when they're finished. They can do the repair with a medical version of super glue and stick your skin back together. Your recovery time is about 5 times faster, and there's very little blood loss because of the small incision, so typically you're not going to have a blood transfusion on most surgeries. So you'll see on this video there's not a whole lot of blood involved in here because of the fact that the incisions were relatively small. You're going to pick one student from each group to be the robotic surgeon. Their goal is to use this device to pick up this guy's liver without touching anything else, and they have 30 seconds to perform that operation. And here's how this works. This control moves the device left and right. This turns the claws. This button and this backup button here open the claws. This button and this backup button here close the claws. To raise it up, you can do from this axis here or from this axis. To travel forward, the best thing is to push this forward and this back like so. And to go backward, you just reverse the operation. You might want to try this out for a little bit to make sure you get familiar with it, so when the students are working with it, you can help them along. Okay, volunteers, at the end of each rotation of a group of students, make sure you take the opportunity to point to the career notations at the end of at the bottom of the circular signs. They tell us what kind of careers are available and what kind of money the kids can expect to make in those careers.